So, Canada's wetlands are these biodiverse areas, essential in cycling natural resources and home to thousands of species. But they're also the same areas that many of us grew up watching frogs and searching for turtles. Canada houses almost one-fourth of global remaining wetlands in our own backyards, but pollution is resulting in the loss of these ecosystems. That's why biologists created the field of ecotoxicology, where ecological tests can measure for contamination. The current standard, however, is labor intensive and requires extra resources for the removal of samples and transporting them outside for the recreation of conditions within a lab or a greenhouse. And if you want an on site biological test, well, there currently isn't a standard practice. So researchers are required to come up with handmade solutions. And while they look a little creative, they're not always reliable, transferable, or repeatable. How would you ever ensure the validity of a test when you have constantly changing equipment? For environmental monitoring, testing is lengthy, it's costly, and it's complicated. Because test samples are removed from the testing site, they don't experience the same site conditions. In addition to this, chemical tests alone do not show if a plant could survive in the current conditions. That's why our solution is to create an on-site biological test that's able to replace these field replications and improve our understanding of environmental health in real time, making it easier to monitor wetlands, municipal storm collection, water treatment plants, and more. It's simple to set up and maintain. It gives you dynamic and realistic results for living organisms. It's repeatable and standardized, and overall, it's just more affordable. The device is simple and effective for testing phytotoxic levels of general or specific contaminants. Just place your seeds in the exposure chamber, position it along your desired water source, and the delivery chamber will draw water up from the soil. The resulting growth or lack of growth will indicate the presence of a contaminant. But we're offering more than just a device. We're making a simple solution even simpler by offering a testing service for our kits. We provide a customized biotest that's set up and collected all by the Ecotox team. The results are then posted on the Ecotoxics user interface. And since we know the sampling area layout, we can help our customers map out their next move. And our customers within environmental consulting are in a growing industry valued at $14.3 billion, driven by increased eco-consciousness and regulatory shifts. In fact, there are almost 24,000 federal contaminated sites in Canada, where 7,000 of those are still open cases, all of which need to be monitored. In 2014, the government spent almost $13,000 per site on assessment alone, something that Ecotoxics can help to lower with our testing kits priced at $300 a kit. That's including labor. This could create a revenue of $3,000 per site. Based on our calculated cost of production, the Ecotoxics expects to break even for production cost at the sale of 335 units. And while environmental testing may seem like a smaller niche market, the lack of direct competition gives us a first mover advantage, helping Ecotox set the standard for environmental biotests. The lack of competition means that we can encapsulate the market and scale our business, making $2.5 million at our first 10,000 units. To enter this market, we've mapped out our commercialization pathway. This helps us see where we still have to go for the launch of our flagship product, the Ecotox Sticks. To date, conceptualization as well as patent filing have already been completed, and we've entered the branding and pre-market phase. Here, we can gather investments to transition from prototyping to plastic production, as well as developing our user interface. We plan to do this all while sending prototypes to key researchers to build our scientific recognition and build pre-marketing awareness via publications. This new pre-market phase is all handled by our team, the BioGryphs, which has recently expanded to include Brooke, our new project manager, as well as myself, the marketing and business developer. And in our race to commercialize, we hope to obtain $200,000 to cover initial startup costs, after which investors can start to see a return on investment within our first production round at the sale of 457 units. This would cover 30 to 45 test sites, the same sites that we want to monitor and protect. Areas where Ecotox can make environmental assessment more accessible and more standardized, ultimately leading to a healthier world for ourselves and for future generations. And at this moment, Brooke and I would like to invite you to ask any questions.
Great, thank you. Who's up first? I know Yvonne's last this time, she said, so.
Katie's first. No, I actually don't have a good question developed just yet.
Oh, okay,
That's
okay.
started, so go ahead,
I'll
Ben.
jump in if that's what you like. Thank you for that presentation. I do appreciate that. Online reporting. Can you just give us a bit of a description on what would be a representative output that would then be found on the application?
Of course. So a lot of this will be our statistical results, in which any part of the team that is receiving these results, whether it be an environmental consulting firm or a government regulation industry or agency, they receive these results online. That way they can interpret them or use our interpretations that we've provided for them. A lot of these tests tend to be a pass or fail test for growth. So they can use these results for their own publications or their own research, or simply to see if a contaminated site is still contaminated or not. So the online publication is making it accessible to all team members.
In this test, are you actually quantifying what the site is contaminated with?
No. So the difference between this test and a chemical test is this is a biological test. So it's similar to a pass or fail germination test. If you put seeds within a location and the contaminated site has toxins that are fatal to those seeds, they won't grow, which is very important for wetlands where they recycle or cycle through their own system. So if a plant can't grow, then your site's too contaminated.
Okay, terrific. Thank you. Over to you, Katie.
What is your plan for manufacturing these devices and getting them out to the market?
Perfect. So we've actually looked into plastic injection molding as the most scalable and price-effective method of production. At the moment, prototyping is done using 3D printing, but we don't believe that the materials used for 3D printing, as well as the manufacturing process, is scalable enough. We want to use autoclavable plastic, and a lot of current scientific equipment is made through plastic injection molding. That's actually where the majority of our initial cost will come from, is from creating that mold for plastic injection molding. From then on, the price or the cost of production decreases as we scale up, because that was our initial cost.
Okay, thank you.
So I may have missed this slide. And I know that everyone's got, again, lots of content. Who's the ultimate customer? Are you selling to government? Are you selling to researchers? Are you selling to consultants? I've heard a bunch of words. So who ultimately is your customer?
All of the above, but we have a certain method of approach. So before we actually commercialize, we're targeting researchers, because that's a two birds, one stone for us. It could possibly start to bring in revenue should they actually want to start purchasing more products, but should they just want the prototype, they can help us with product development to improve our user interface as well as the product, the field deployable assay, if you will. And then from there, once we actually get to commercialization, environmental consultants are our target customer, because it is the largest market share for environmental testing. So therefore, they are the ones that we would want on our team.
Great. And my last question is more on the data you're capturing. So is there an opportunity to sell that data in an aggregate form, right? So just a thought on the data you're collecting and what the strategy is with that.
Absolutely. So because we're offering our product to customers, confidentiality is very important. So a lot of times they won't want this information shared. However, governments are different. So should governments start to want to adopt our product, especially once it becomes more of a standard for environmental testing, a lot of that data may be published in the form of a meta-analysis, where you have the collective data from multiple tests, multiple agencies within, for example, the government of Canada. They can use that to explain why they have regulatory standards for developers, such as residential developers or commercial developers. And they can also show that data to, for example, a Paris Agreement, to show how they've improved their contamination levels or decreased these contamination levels.
And do you foresee any regulations coming down from the federal government, whatever that will benefit, that'll kind of incentivize people that they're going to have to do this? So do you see anything that will be in your favor as a business?
Absolutely. So developers already have to prove that water systems that they're building houses along are not contaminated. Otherwise, they need to come up with fencing or blocking it off for resident safety. So these kinds of tests are already necessary for urban developers. And when you go into research, there is an increasing need. And as regulations such as the new Biden administration, who might be creating more environmental regulations that unfortunately Trump had taken away, these regulations would push private businesses to prove that they are meeting the minimum dumping standard, for example, or that they are not leaving